Hello and welcome back to a new video. In this one, we're going to be covering Go's methods and functions. Compare them, use some defensive coding practices and conventions when writing functions and methods, and call back to previous knowledge where functions are values. In particular, we're going to be covering methods, functions, pointer receivers, value receivers, what those actually are, and look at some documentation, and then what pointer receivers and nil have to do with one another. As we are familiar with in this series, we can have functions, which are repeatable blocks of code. Here, I will create a function called say hi, and it will just print hello, or let's go with hi since that is what the function name is, and then we'll call it up in the main function. So we'll just do say hi, and that's it. Let's go ahead and run this, and we get hi printed to the screen. And we also know that we can add any number of parameters to a function to customize its behavior. So I can have a name passed in there that's going to be of type string, and we'll say hi to the person or the name that was passed in. So %s, pass in that name at the end, and here we'll just pass in my name. So then we save, we'll do another go run, and we get hi Colton. One thing that programmers interchangeably throw around are the words functions and methods. And most of the time when you're talking about them, they mean the same thing, but some can be quite pedantic about each word's meaning. So the key attribute to what a function is in Go is that they're not associated with any particular type. So they're not associated with a struct. So if you come from Java or C#, these appear to be like static functions where there is no prefixed object that you need to use to call that particular method or function. Let's take a look at the Go package strings to better understand methods and how they're different from functions. So the strings package contains both functions and methods, and actually a couple structs. So we can read through the documentation and whatnot, and we can see that we have the index and we have a bunch of functions here. We can keep on going, but I'm not going to scroll through all of that. We're just going to go through our index up here. So we can see that we have examples of whatever's going on. Then they have functions listed, types, and builder, and then all of its methods that are associated with it, so on and so forth. So let's first take a look at what function documentation looks like. And I'm going to pick a relatively just basic function that this has, and we're going to go with index. And so index, if you haven't used it before, as this documentation says, returns the index of the first instance of the substring in S or -1. So basically it finds another string within a string and gives you the index that it starts at. If we look at the documentation of it, it's what we're super familiar with. We have the func keyword, name of the function, and then any amount of parameters that go after it, and the return value. But now let's go to the builder type that's located in this package. So the builder type is just like string builder over in Java or C# also I think has string builder, but it's where you can combine a bunch of strings together in a memory efficient way and have a couple other methods associated to work on that string. So we'll just take a look at the length function or method now, and we'll see that the syntax is slightly different. We have the func keyword, name of the function or method, and its return type, but there's this space in between. Now what is that in particular? And that is the receiver type, basically saying that you can only call this len function on a builder type. And so we can optionally have this star right here. So if you've watched a previous video or if you're familiar with pointers, you would know that this is saying it's a function that can only be called on a builder pointer or an instance of builder, pretty much, because an instance of objects are basically pointers in Go. And that's the basics of it. It's essentially saying you have to have a builder, maybe called B, whatever you want to call it, and then you can do b.len. Let's go take a look at this over in code. To begin to demonstrate this in code, let's create a struct called cat. So type cat, which is a struct, and we'll just say for simplicity's sake that every cat struct will just have a name. Now we can go ahead and write functions or methods, since they will be tied to a struct, that we can then call once we have instances of cat. So just to start off, we'll go ahead and create a cat down here. So my cat, and it will be equal to a cat with the name set to emoji. And down here, we'll just do a print line of my cat. So this is stuff that we have already covered before, creating a struct, calling it, printing it out, and whatnot. But there are two distinct types of method receivers that we can have, or receivers and functions that we can have. One is the value receiver, and two, we can have a pointer receiver. Now, in the documentation that we reviewed earlier, everything was just a pointer receiver. And I'll explain that here soon, but that was primarily just by idiomatic and convention's sake in Go. Let's first cover what a value receiver is and when to use one. A value receiver is when we're writing a method for a struct and we're only ever reading from the struct. We're not trying to manipulate it or anything. So here I'm going to write a method called, so we'll start with func and we'll just say it's going to be meow. And this will just print out meow. Now we cannot call meow on any particular cat that we've created. As we can see, I try to do my cat and we only have access to its name property. So when we go back up here, we need to create a receiver. And so the receiver will go in some extra parentheses here and it will be for a cat. So then back down here, we can call cat.meow and we should be good. So go back here, let me cd into the functions and methods and then clear this, go run, and we get meow, which is the method that we had called, and then also the struct that we just printed out. So this is fine. We can, if we're only reading from the struct or not even reading anything at all, we can just use a value receiver. But what if we wanted to manipulate or change content within that struct? Well, then we need to use a pointer receiver. So let's go ahead and create another function or method, and it's going to be named change name. And for this, it's going to take in a new name that's of type string, and here's where we'll manipulate it. But we can't quite manipulate it yet because we don't know what we're accessing. So in here, we'll go ahead and say we're going to have a receiver called C, or actually we'll go with cat, and it's going to be a cat pointer. So then when we go to manipulate the cat, we can just say cat.name is equal to Finn, my second cat. So here, this is pointer receiver syntax, meaning that we need a reference to the cat that we're talking about so that we can therefore change some of its properties. Here, we only get a value. We get a copy. We can't do anything with copies. So here we have to have the pointer. So down here, I will call my cat.change name. And actually, I just changed it manually here, even though I passed that in. So we'll just change this to a new name and we'll pass in Finn down here. So when I go to run, let's bring this up, we get the meow printed out like we had earlier. But then now when the cat is printed out, its name is Finn. Now, you would think when I have a particular file, let's say that this cat struct and all of its methods were in the same file elsewhere, you would think that, okay, for every function that I have for this cat that only reads or doesn't read anything from the struct, I will just make that a value receiver. And then anything that needs to modify the struct will have pointer receivers. So that's not necessarily the case. What you should do is just make everything a pointer receiver at that point. There's not much of a performance hit. You don't need to worry about it. So as soon as you have one pointer receiver in that file or a method for a struct, go ahead and make everything a pointer receiver so that you can then call it safe for compilation and everything else. Now, before we end the video, I would like to give you one warning. Remember that values and pointers have different zero values. For instance, a value type like an int has the zero value of 0, whereas pointers have the zero value of nil, as in we cannot do any operation when we have a nil pointer. So let's demonstrate this. We have some very dangerous code right here because we are not checking to see if this cat pointer is nil or not. So when I create a var my cat and I'm going to remove all this, I'll say it's going to be a cat pointer that is nil. Let's see what happens when we run this. I do a go run and the cat tries to meow, can't do it, and it definitely cannot change name on when it does not have any sort of address to go access to change a name variable of. So to prevent this, what you need to do is say if cat is nil, then return. You need to exit early so nothing happens. So now when we go to run, after we take out the first meow reference, clear, and we run, we get nil printed out to the screen because there was no cat and we returned early. And that's it for the video. Thank you for sticking around to the end, and I really hope you learned something. If you enjoyed this video and did learn something, feel free to go ahead and like and subscribe, and I'll see you in the next one.